Hello students, let us begin with the second session on physics problems that came in AIEEE 2009 paper. First question in this session is that we have to read two statements 1 and 2, and then based on the statement 1 and 2 we have to select the correct option which follows the given statements. Okay, now let us read the first statement. The temperature dependence of resistance is usually given as R equal to R naught 1 plus alpha delta T. The resistance of the wire changes from 100 ohm to 150 ohm when its temperature is increased from 27 degree centigrade to 227 degree centigrade. This implies that alpha is equal to 2.5 into 10 to the power minus 3 per degree centigrade. Okay, now let us do some analysis, mathematical analysis. The actual temperature dependence of resistance is given by RT equal to R naught 1 plus alpha temperature T, where R naught is the resistance at temperature T equal to 0 degree centigrade. Okay, now in the given case we are given two temperatures, that is 27 degree centigrade, which will be equal to 300 Kelvin. Okay, and T2 is given as 227 degree centigrade, which is equal to 500 Kelvin, and the resistance is 100, and at high temperature it is given as 150. So this is R1, this is R2. We are not given what is the resistance at 0 degree centigrade or 273 Kelvin. We are not given this temperature. Sorry, the resistance at temperature 0 degree centigrade or 273 Kelvin. So this is not given to us. Now what we can do is we can write R2 as equal to R naught 1 plus alpha T2, and R1 will be equal to R naught 1 plus alpha T1. Now if we take the division of these two expressions, we will get R2 by R1 equal to 1 plus alpha T2 divided by 1 plus alpha T1. Okay, now if we cross multiply we will get R2 plus R2 T1 times alpha is equal to R1 plus R1 T2 times alpha. Therefore alpha can be written as R2 minus R1 divided by R1 T2 minus R2 T1. Okay, now the given values are R2 is 150, R1 is 100. Okay, and the temperatures are R1 is how much? 100, temperature is 500 Kelvin, minus R2 is 150 and temperature is 300. Okay, now if we solve this we will get 50 divided by 5 into 10 to the power 4 minus 4.5 into 10 to the power 4. Now if we solve this we will get 1 into 10 to the power minus 2 per degree centigrade, per degree Kelvin as the alpha, but herein we are given it as 2.5 into 10 to the power minus 3. So the statement 1 is false. Okay, although the formula is correct, but the statement 1 is false looking at into the calculation. Now let us look at the statement 2. Now statement 2 says that R is equal to Ri 1 plus alpha delta T is valid only when the change in temperature delta T is small and delta R equal to R minus R naught is much less than the initial resistance. Now look at this expression. Alpha is equal to R2 minus R1 divided by R1 T2 minus R2 T1. Now if the change in temperature is very less, then this delta R, which is actually much less than R naught, can be written as delta R. And since R1 and R2 they do not vary much, we can write it as R naught. R1 can be written as R naught and R2 can also be written as R naught, and we will get change in temperature delta T. Okay. Now with these assumptions, that is R2, R1, they are very close by, or R2 minus R1 is much less than R1. Okay, then alpha will be equal to delta R upon delta T and R naught, where R naught is R1 in this case. Okay, so keeping this thing in mind, we can write it as R naught alpha delta T equal to delta R, which is R minus R naught. Okay, now solving this, we will get R is equal to R naught 1 plus alpha delta T. Now this expression is only true if R and R naught they do not vary much and delta T is given to us. Okay, so statement B or statement 2 is correct. So statement 1 is false and statement 2 is true. Okay, now look at the options. Statement 1 is false and statement 2 is true. Option D is correct.